Hello, I'm Major Nigel Bovey, Vice Chair of the Christian Evidence Society, and welcome to Questions of Our Times. Today's question is, are we alone in the universe? My guest today spends much of her time gazing into space. Not, it should be said, aimlessly. On the contrary, while a physics student at MIT, she co-discovered a comet. Now it is known as the Wiseman Skiff comet. Encouraged by the discovery, she gained a doctorate in astronomy at Harvard University. And today, as senior astrophysicist at the Goddard Space Flight Center, which is a NASA research laboratory, she peers into deep space to study the process of star and planet formation. Director of the program of the Dialogue on Science, Ethics and Religion for the American Association for the Advancement of Science. Here to talk with me in a personal capacity today is Dr. Jennifer Wiseman. Jennifer. Hello, all the way from the States.
Yes, hello. Actually, it looks like I'm coming to you from outer space, doesn't it?
Let's not spoil the illusion. We will talk about Capricorn later on. Jennifer, it's lovely to see you. Thank you for joining us. You have had quite a journey, and maybe into space in a different sense. Where did your journey begin? Your journey into becoming a space scientist begin? If you don't mind me saying, it's something that sort of little boys want to be a spaceman. Obviously, little girls want to get involved in space as well at some point. How did you come about it?
Well, I think it came quite naturally, although I didn't grow up thinking, I want to become an astronomer or I want to become a scientist. I grew up in a rural area in the center of the United States, in the state of Arkansas. And there's a region there that's very beautiful called the Ozarks. They're small, hilly regions. And I grew up near a small town and on a family farm. And out there in the country, I had a lot of chance to think about the natural world. I mean, we had animals and we had a lot of wildlife, and I enjoyed just exploring around outside. I love nature and I love rivers and streams. And we also had a beautiful night sky, which is hard to find these days on our planet that's so light polluted. But we were able to see many, many stars on clear nights. And my parents and I would sometimes go for walks together at night, and I would just look up at the stars, and I was just curious. I wanted to know what it was like, and imagined if I could just blink my eyes and be up around some of these stars, what would it be like? And then around the time I was entering into my teenage years and so forth, these probes that NASA had sent into the outer solar system were starting to send back the first close-up images of the outer planets in our solar system and their moons. So weird exotic places like Europa, ice-covered moon of Jupiter, or Io, full of volcanoes, or Triton and Titan, and these interesting moons of the outer planets. And I was fascinated by this. I wanted to go to those moons, but I also wanted to be a part of this enterprise of exploring these places. I wasn't quite sure how, should you try to become an engineer or an astronaut or a scientist, and how in the world would you do any of those things? I didn't know, but I was curious. And also around that time, there were a lot of science fiction movies coming out, the first Star Wars movies and things like that. So space was on everybody's mind. So I kind of grew up in that environment, and loving nature as I did, science became a natural subject that I liked, because science really is the systematic study of the natural world.
Yeah, I can remember the first time I had a telescope. It's only it's not as big as your telescopes by any means, of course, but little thing on a tripod, and I actually found the moons of Jupiter, and oh my goodness, what a sight. And then I managed to find the rings on Saturn one night, and it takes your breath away, doesn't it? Even though it's only a little pinprick. When you realize what it is, it's quite stunning, isn't it? And almost magical, certainly mystical.
Well, I tell you what, people and the audience, you can do this too. The same observations that Galileo did 400 years ago, you can do with even a good pair of binoculars on a clear night if you're in a fairly dark place, is find Jupiter and look very close to Jupiter in sort of a plane right next to it. You'll see some tiny faint dots. Those are the inner moons of Jupiter, same thing Galileo saw. And if you look night after night, you see them moving around. They're in different positions on different sides of Jupiter. And that's how Galileo realized that these moons were orbiting Jupiter. And you can have that same personal discovery even with good binoculars.
Talking of telescopes, then, you've worked with some of the world's largest radio and space telescopes, such as the Hubble Space Telescope. What area of research are you engaged in at the moment?
To be honest, mostly I'm engaged in answering too many emails every day and paperwork and the kinds of more mundane parts of all of our lives.
A bit more down to earth then, isn't it?
A bit more down to earth. But as I have opportunity, I'm still involved with my research group in studying how stars form. And in fact, star formation is still a very vibrant and active process in our galaxy and in other galaxies. You know, you see the stars, but actually there's a lot of material between stars. And in some of these wispy clouds of gas and dust, there's enough material that it can start to collapse into clumps under its own gravitational pull. And if there's enough of this interstellar gas clumping together, it will collapse further into what we call protostars, which are basically on their way to becoming stars. It's a very interesting process, and some of these regions, these stellar nurseries that we observe, you cannot really see into with a regular kind of optical light telescope because there's so much dust in these clouds that it obscures the light. But if you look with radio telescopes or infrared telescopes, you can peer more deeply into these young stellar nurseries and see the young stars. With radio telescopes, we can see the gas coming together and coalescing into filaments and eventually into clumps of new stars. And infrared telescopes can actually pick up the heated young stellar objects that are emerging from this process. And then once the stars actually turn on, meaning the process of fusion begins in the core of these clumps of gas, that means hydrogen atoms combine and they form helium atoms and other products, including light. And so you have a star, and the brightest stars actually have enough energy to light up that surrounding gas around them in that gas cloud and create beautiful colors. So some of the most spectacular images that we love from astronomy are these nebulae that are really signposts of recent star formation, where the infant stars are ionizing the surrounding leftover gas, and that creates these beautiful colors that we love. I can show you some pictures if
that'd be fantastic. Yeah, because it's very difficult for us to imagine. I mean, you see this from time to time. I know not every day, but you know, yeah, please do. Let's show us some beauty from out there.
All right. Well, let's hope that the beauty of screen sharing actually works. Can you see a bunch of stars here?
That looks like a color blindness test to me, but yeah, I guess that's the stars.
Yeah, it might be problematic for some folks, but this is actually a collection of stars. And we can't see this many stars anymore from the ground on our planet, but this is a very crowded cluster as imaged with the newest camera on the Hubble Space Telescope. And it's able, because of its sharp vision, because it's above the Earth's atmosphere, it's orbiting the Earth high enough to get above most of the atmosphere. It doesn't have to look through a turbulent atmosphere to see, and can get much sharper, higher resolution images. So here you can differentiate star from star. Even in a very crowded cluster, you can see that stars are not all the same. They're different colors, they're different brightnesses. To me, this looks like a collection of gemstones. I find it really beautiful, and it's called Omega Centauri. And here's one of these regions I talked to you about, where the stars have just recently formed and they're lighting up the surrounding leftover gas. The nebula is bright with color based on being lit up from light from these new stars that have formed. Now you asked about my growing up. So here's me all bundled up on a very cold day in Arkansas in our family farm, feeding the cattle in the snow. But I didn't grow up in a sophisticated scientific setting. I grew up out in the country where I could observe nature and really grew to love the natural world that way. With sunsets and flowers and cows and skies, and I still like to get back there as often as I can. But I'll close this little discussion with you asked about telescopes. So we use different kinds of telescopes to get different kinds of information. So astronomy these days uses a variety of telescopes. We have telescopes in space. The most famous one on the top there is the Hubble telescope, but there are other telescopes in space as well. And we also use and need different kinds of observatories on the ground. Those in the lower left are the Keck telescopes in Hawaii. And on the right down there is a whole array of radio telescopes in Chile and South America that are just a fabulous observatory for the kinds of light it's trying to see. And we need all this different kind of information to give us the fuller understanding of whatever it is we're trying to learn about, whether it's galaxies or stars, or planets. So I've used all of these kinds of telescopes in my astronomical career, and we're building and designing future ones that will be even more powerful. Oh, I guess I should mention, everyone's going to want to know. We have a new space telescope that's joining the others, and it's called the Webb Space Telescope. It's already out where it's going to be operating, which is over 1 million miles away from the Earth. It's an infrared telescope. It's got to be kept very cold, so it has these sun shields that you see in kind of the pink color at the bottom there that are always between the telescope and the sun and the Earth, just to block out as much heat and interference as possible. And this observatory, once it gets doing science later this year, will complement other telescopes like the Hubble, because it sees, this telescope is an infrared light telescope, whereas Hubble will be seeing the visible light and the ultraviolet light that the Webb cannot see. And so they'll work in a complementary fashion.
Literally covering the spectrum.
Yeah.
I mean, it's unimaginable. You just said there, 1 million miles away. I mean, this is almost it is unimaginable for many of us. What are the most exciting, the most intriguing discoveries that you're making in astronomy at the moment, or recently?
Oh my! I hope you have several hours here. But,
no, we don't.
I guess you don't. Let me see if I can just touch on two or three kind of realms where there's the most excitement right now in the field of astronomy. I don't know whether to start near or far, but I'll start near. We are really interested well, first of all, I'll start with our own solar system. I mean, we are really, really excited about our own solar system. We have so much left to learn about our own solar system. We have probes now on Mars. Probes are being designed to go to Europa, which is, as we mentioned, the moon of Jupiter, and it appears that Europa has an ocean under its icy crust, and it would be really, really interesting to study that water and see what it's like. Sometimes plumes of water vapor are ejected out from the surface of Europa. And we're also detecting some objects passing through our solar system that you can study their trajectory and figure out that they were actually ejected from other star systems. And so we found a couple of these objects in recent years that were ejected from other star systems. One is called Oumuamua. It's an asteroid-like thing. And one is Comet Borisov, which is a really carbon-rich comet that didn't originate in our own solar system. So these interstellar objects are going to be discovered more and more. And a lot of them are actually being discovered by people, amateur astronomers even, who have very good telescopes and have the time and capability to survey the sky. And then we follow up with the more professional telescopes. So our own solar system is very interesting. Then we also, moving out, we're finding that other stars also have planets. So we call those exoplanets because they are planets outside our solar system. Maybe I can share my screen one more time if that's
Yeah,
okay.
good. It'll be good.
Now, when I was back in graduate school, we didn't even know if there were planets orbiting stars other than our sun. And now, thanks to new techniques and discoveries, we have found that planets are common around other stars. And we've already discovered thousands of them, and we can statistically extrapolate from that and realize that most stars have at least one planet. So the name of the game now is to try to characterize those exoplanets and see how they compare to our own solar system. And then, so that's an artist's conception, but of a real system that has 6 planets orbiting in very tight orbits around the parent star. Most of these planets are discovered indirectly by seeing when the star itself appears to dim or wobble based on the orbits of planets around it. But we're hoping to build telescopes in the future that can take more, real pictures of these systems. Yeah.
So that would be like a bit like an eclipse, would it be, where the planet just passes in front of the star, the light dims, and that enables an astrophysicist or an astronomer to say, aha, that's interesting. I wonder what that is.
Well, yeah, and it enables much more than that, because you can measure the amount that the star dims and the periodicity by which it dims and then returns to its normal brightness. And that can tell you how big and how many of these planets are orbiting it. And then if you can get a little bit more information, like if the star wobbles a little bit due to the mutual gravitational pull between the star and its planets, you can tell how massive these planets are. So, and then thirdly, you can tell from the sunlight that comes through the outer parts of that planet's atmosphere on its way to our telescope, you can tell what that atmosphere is composed of, because the atmosphere will absorb some of that starlight in very precise colors or frequencies. And it's that pattern of absorption that gives us information about what's in the atmosphere. And of course, we want to know whether these planets have things like our own Earth's atmosphere has. Do they have oxygen? Do they have nitrogen? And we've already found water vapor in a lot of these systems. So we're able to do some of these crude characterizations even now with our telescopes, and then future telescopes will be able to do even more imaging of these systems. So I should note that this is not just something in deep space. Even our nearest stars to our sun in the Alpha Centauri system seem to have planets, and the very nearest one of these is called Proxima Centauri, which you can see down in the bottom of this picture. It's kind of the little sister to the very bright Alpha Centauri. But Proxima Centauri has a planet that's orbiting it in what we might call the habitable zone, which means it's a temperate region where its temperature might be just right to have, if it had water, to keep it as liquid water. So that's our closest star. So of course we would love to learn more about this neighboring system to us, and of course many others. And then finally, just that's an artist's imagination of what it would look like.
It's very clear. Good picture.
just to finish answering your question about what's the most exciting things. I think still I'm amazed by looking far beyond our Milky Way galaxy. It's only been 100 years that we've known that there are these entities called galaxies like this that have hundreds of billions of stars and lots of the interstellar clouds I mentioned where stars are still forming. And to realize that our own sun is in one of these galaxies. This galaxy is a very nice one I like, called NGC 1309. We can't get far enough out of our own Milky Way to take a selfie like this, but we know enough from looking around that it probably looks like this. This is an artist's picture of our own galaxy. So many stars in the middle that the light's just blending together. And you can see toward the bottom there a little arrow that says our own solar system next to one of the spiral arms. So we think that our sun and us, we right now, are orbiting a star in kind of median outskirts of the Milky Way. And we also believe there's a massive entity right in the core called a supermassive black hole. Centers of galaxies tend to be the place where over long periods of time, dead stars eventually migrate and their gravity pulls them together and they become a supermassive entity that collapses into a very small volume. And that really has a major distorting effect on space itself. And so we believe the cores of most galaxies have these supermassive black holes. You wouldn't want to get too close and get sucked in. But right around them, you have orbiting material, orbiting stars that can get very bright. And so we see these in other galaxies. But I just want to close this thought by saying, you know, as we look out and see a universe that's filled with literally hundreds of billions of galaxies. Here's the Hubble Deep Field showing just a small field of view, and thousands of these galaxies are showing up. It's mind-boggling. And we're also understanding, of course, that some of these galaxies are closer to us than others. So, and they've all, of course, we're seeing them all as they were in the past, because it's taken light time to get to us from anything we look at in space. And some of these galaxies are millions of light years away. A light year is a distance, the distance that light travels in a year. And so we're seeing them as they were millions of years ago. And some of them are even billions of years ago away, billions of light years away. So we're seeing them as they were near the beginning of our 13.8 billion year old universe. And if we start realizing that looking deeper into space as our telescopes get better and see more faint galaxies means looking back in time, we're actually seeing back now as our telescopes have gotten better over the years here from top to bottom, we're seeing closer and closer to the beginning of our universe. So we're seeing what galaxies were like within the first 0.8 of the 13.8 billion year history of the universe. And we can line up the galaxies, you know, kind of pull them out of these deep fields and line them up by their distances. So here, the more distant ones are on the right, the more nearby ones are on the left. And that kind of gives you a sense of how galaxies have changed over time, because the more distant ones, we're seeing them as they were farther back in time. And you can see that they were smaller. They hadn't yet taken on these big structures. They hadn't yet merged together with other galaxies. We know now that galaxies get bigger by merging with other galaxies. And also generations of stars come and go. The star formation is a very important part of this whole process, and stars don't last forever. The biggest ones don't last very long at all, and they enrich the next generation of stars. So we know our sun is in the Milky Way galaxy, which would be like the ones on the left here. And our sun is not a first generation star. It contains material from previous generations of stars. And I'm so grateful, because this process creates carbon and oxygen and things we need to enable solids like planets to form in our era, and even to support life on at least one planet. So I think one of the neatest things we're discovering in astronomy is just how the universe has changed over time, from a phenomenal beginning about 13.8 billion years ago, and changing, maturing, if you will, to the point where galaxies like our own have heavy materials and can have planets and even life. And of course, there's some exotic things we're studying: dark matter, dark energy, even gravitational waves, but maybe we can get into that.
I mean, you're talking huge, massive scales here, aren't you? You know, in terms of distances, you're talking incredible leaps. I mean, yeah, Neil Armstrong famously speaks about a leap, but you're talking about an enormous leaps in complexity, in technology and human ingenuity. Now, what philosophical questions are these discoveries raising, you know, among the scientific and perhaps even the religious communities?
Well, there are kind of three driving questions that I think, I mean, they're explicitly driving NASA's astrophysics program, but they're kind of implicitly also driving the broader philosophical questions that people have that they hope science can answer in part. One of them is, how did we get here? And how does the universe work? You know, what are all these forces like dark energy. How does gravity intersect with dark energy and these quantum level processes and subatomic forces, things like that? How does the universe work? And then a driving question is also, are we alone? Which is the topic of our program tonight. And that is now a huge undertaking to see if there are other planetary systems similar to our own, and could there possibly be life? And if so, how would we actually know that? And would we actually have a chance to have any meaningful interaction with other life? So these are all scientific questions that also fertilize richer questions, because there are questions that come about when you look, for example, at how the universe has evolved over time to the point where it supports at least one planet with life that's asking questions like this. It asks, the question comes, well, is that what the universe is for? Does the universe have a purpose? And are we the purpose? And so this is beyond science, right? Science can answer the questions of, how long has the universe been around, and how do stars form, and how do they shine? And we can use telescopes and microscopes to make measurements of the physical world and understand the scientific processes, but science is not the right tool. In fact, it wasn't designed to answer these bigger questions of, is there a purpose? How do I live my life? Are evil and good really real? Is there a God? Can I communicate with God? These are kind of questions beyond science, but I think what we're learning through science enriches these questions, because now we have to ask, well, if there's life beyond Earth, what's that life like? And does it have the same problems and the same hopes that we do? And those kinds of things that our curiosity can't help but want to know.
And does the discovery of exoplanets and Earth-like habitable zones, I think you called them, didn't it? Habitable zones. Does the discovery of thousands of billions of planets and stars increase or decrease the likelihood that there is life out there, that we are in fact not alone in the universe?
Well, it's fascinating, because there's this interesting, almost a tug of war between, as we get more and more information about whether it's kind of pushing us in the direction of thinking, well, the universe must be filled with life, and the other direction as, wow, life would be really hard to sustain. And the more information we get, it goes back and forth. So in one sense, it looks like there's a fantastic possibility for life beyond Earth, simply because the sheer number of exoplanets. I mean, as I told you, we've found statistically that most stars seem to have at least one planet. Now, some of them don't have any planets, and some of them, like our own, have more than one planet. But planets are common. If there are at least 200 billion stars in our Milky Way galaxy, that means there must be something like 200 billion planets. So even in our own galaxy, and of course there are hundreds of billions of other galaxies, as I showed you in the picture. So it's mind-boggling, the possibilities of how many planets there are. And of course, there could be life on the planets, but there could be life on those moons. That's why we're around the planet. So we're interested in our own solar system, even though we haven't found any life beyond Earth yet. We're interested in looking for life that may exist or have existed on Mars, where we know there was liquid water on the surface of Mars in the past. And we're also looking at the moons of places like Jupiter. Its moons may have liquid water oceans, and wherever there's liquid water on Earth, we find life. So that's kind of a place we want to look first elsewhere. So if we think about all those planets in the galaxy and all their moons, even if most planets don't have life, surely that increases the odds of finding some kind of life somewhere. That is a tug of war with another piece of information that we're gathering, which is what the environment is like for most of these planets, because it turns out that most stars in the galaxy are smaller than our sun. They're called red dwarfs. And by far, the majority of stars are these smaller dwarf stars. And so the region around those stars where you can have comfortable temperatures, and for various reasons, we think that life needs to have some capability of having a liquid water environment or internal systems. So you need liquid water for life, and probably carbon as well. And to have a liquid water environment, you need a temperate zone. And to get to that temperate zone near these dwarf stars, you have to get much closer to the star than we are to our sun. Well, it turns out that those dwarf stars are also really unstable for various reasons of physics. They have lots of these flares, and these events that eject energetic particles, and these flares that would basically saturate and irradiate these planets that are orbiting in that temperate zone very close to the star over and over and over again, perhaps wipe out the atmosphere and certainly wipe out any chance for a long-term stability for advanced life to form and thrive. And so if that's the case, then environments in most of these planetary systems are not really conducive for long periods of time that we think, at least from our one experience on planet Earth, it took for life to arise. So for complex life to arrive, it seems that on planet Earth, simple life arose rather early. So that's encouraging. Maybe life is robust, and however one believes it starts, maybe it's not so difficult using basic components that we find on planets like Earth. But it took billions of years for Earth's life to start evolving into the more complicated forms like we know. And so if these other systems don't have billions of years of stability to do that, they might not ever have the chance to reach advanced life stages.
Jennifer, some people say, though, that for us to have not only life on planet Earth, but to what we might call complex life and intelligent life such as human beings, the only reason it is here is because the physics is so finely tuned, so finely balanced, the right amount of all the elements that you talk about coming from stars, the carbon, the fresh water, all these things. It's a finely tuned, a bit like Goldilocks's porridge. It's just right. Now, some people say that because it's finely tuned, that's evidence of the divine designer. Do you subscribe to that idea?
Well, I think first we have to be clear on what we mean by fine tuning. So certainly our Earth is very comfortable for life. And you could think of it as a chicken and egg thing. Is the Earth, are we here because the Earth is perfectly designed for life? Or are we here simply because this is the only kind of life that could exist on this kind of planet? And you might have another kind of planet where a different kind of life would be more sustainable than our kind of life. So there's that, but there's a bigger question of fine tuning, which is that the whole universe has certain fundamental constants that have driven the history of our universe, the expansion of the universe, that what came out of the Big Bang, the fact that we can have atoms and molecules, the fact that atoms are stable, molecules are stable, the fact that we can have a long enough time for gravity to pull together gases to create stars and then eventually planets. The fact that the whole universe didn't expand so fast that everything just flew away from each other too soon for stars and planets, too quickly for stars and planets to form, nor was it so gravitationally bound that it just immediately collapsed back in on itself. So there's lots of these larger questions that, if the universe were just slightly different in some of these physical constants, we wouldn't have a chance to be here. And that's an interesting observation. But in both cases, you ask the question, since we seem to be fortunate in one way or another to be in a universe and on a planet that enables life that we experience, is that some kind of evidence or even proof of a divine entity? And I really hesitate to go down that path, and I'll tell you why. Because I do believe in God, and I do believe that we are part of God's wonderful creation. But I don't think looking for evidence of fine-tuning, at least for me, is a satisfying way of trying to prove that. Because if it turns out that next week we find out through physics that actually those fundamental constants of the universe don't have to be really fine-tuned, that you could end up with a universe that supports life with all kinds of different parameters of fundamental physics, then where does your argument go for, to me, my faith says that it's starting in the wrong place. I start with an understanding that God is responsible for the universe, whatever's out there. And then science teaches us the details, and we learn more and more and more. We may learn, next week that there are a million planets like Earth, and Earth is not unique at all. And to me, that would be just as glorious and would cause me to say, wow, thank you, God, this is really cool, as it would be if we find out that Earth is truly unique. So I hesitate to say that one finding or another in science is more indicative of a God behind it all than another. And I think it's it's mismatching the tool with the question. So trying to answer a bigger theological or philosophical question with a tool of science isn't always a good match, nor is answering a science question with theology or philosophy a good match. That said, I will say that what we're learning in science and what we're observing in the universe deeply enriches my appreciation of God and my faith life. And so I don't use science to try to prove God in my life, but I am amazed at what we're learning through science. And I'm very grateful for the gift of science that helps us learn more about the universe. And for people of faith who appreciate the Bible, there's a wonderful psalm, like a poem called Psalm 19, that says, "The heavens declare the glory of God, and the skies proclaim the work of his hands. And day after day, they're pouring forth speech, and night after night knowledge, but without using words." That there's something we glean from studying the universe, that it doesn't require words, but we all know there's something fantastic about the universe. And for a person of faith, that's declaring even more glory about the God behind it.
When you look into the heavens, then, as you did as a girl on the farm, and you had an appreciation and a love for nature. When you look in the heavens, do you find evidence for God? Do you have a picture of God? Does it speak to you in some way of God? And if so, how does that do that?
Well, again, I don't usually, and I didn't even as a child sort of try to glean something about, glean God from looking directly into the heavens or even into the natural world. But I am, I think, inspired to think more appreciatively of God's power and creativity for enabling this natural world that we live in, for enabling a universe that operates under these physical principles that we can now study through science. I went into physics to study physics as a university student because I wanted to understand those fundamental principles that are driving the natural world around me. And I always understood that to be a part of God's gracious creation. So these things all fit together very well. And of course, I'm curious to know what these other planets and moons are like. Could there be life beyond? And I'm not the first person, of course, to wonder if there is advanced life elsewhere. Do they have the same questions? Do they have the same problems? Do they have the same thoughts? Do they do they acknowledge the same God? I mean, even C.S. Lewis, the wonderful scholar and writer, wrote about his in a science fiction kind of way, the spiritual state of life on other planets, what that might be like, what their relationship with God might be like. So of course, growing up and even today, I have these deeper questions about how the entire universe relates to its creator. And I think about that a lot. And of course, the more we learn about the universe and possibly a multiverse, the richer and deeper those questions become.
My last question then, Jennifer, before we go to the whole stream that's coming in from our audience tonight, which is fantastic to see. You made the very clear distinction just a few minutes ago between faith and science, and not using a science tool to answer a faith question. So what questions does your faith answer that your science doesn't address?
Oh, yes. Well, that's a good one. So let's look at evil and suffering, for example. I mean, that tends to be the biggest question that we all have. Why is there suffering and evil? Why do people intentionally harm one another? I mean, I don't have to say much for all of us to realize that there are horrible evils going on our planet right now, of people one to another doing to each other. And of course, there are what we call natural hazards and disasters as well. And so one can say, well, why is this the case? And and there are different kinds of why. So if you ask why with your science tool, well, we can certainly understand the human brain, we can understand behavioral tendencies, we can understand perhaps the development of survival tendencies in different groups, we can understand for the natural processes of the planet, we understand plate tectonics that creates earthquakes. So we can answer those kind of mechanical questions of why with science. But the bigger questions of, why is there evil at all? And why do we recognize it? If this is just natural, then why are we troubled when, children are abused, or when trouble comes, or when there's murder, or when there's even a break in a relationship, or something a little closer to home, a disappointment with someone you trusted, or a health diagnosis that's deeply troubling and disturbing, a disappointment, a hurt, an evil, a wrong. Are these things real? Are we supposed to just think that these are simply outpourings of different synapses in our brains, but have no deeper meaning? And here is where my faith, Christian faith, is much more helpful to me than the science. Science can tell me the mechanics of why things are happening, but not the deeper whys of capital W, why. And in my Christian faith, clearly is outlined in Scripture, human nature. Scripture is not a great science textbook, but it is a wonderful textbook on human nature and how all of us have a tendency to self-centeredness, to selfishness, and to what the Bible would call sin, disobedience to the God who's responsible for our lives. And yet the God who's responsible for the universe and the life in it is a God of love, and it gives us freedom of choice and gives us an invitation to come back into fellowship with God. And that's not by our own, efforts and recognition of these things in a sense that we can completely reform ourselves. But it is in the sense that we can actually start communicating with God. We can receive forgiveness. In Christianity, we actually recognize that the God of the universe has actually experienced life in the universe in the person of Jesus Christ, and has shown in that sense that God of the universe actually cares about us personally. This is an awesome, awesome recognition. And that through Jesus' life and his death and his, miraculous resurrection, we are indicated that there's something more going on than we're fully aware of, and that God has something very good for us in keeping with a relationship with God. So I think one of the most amazing things that I experience as a human being is the reality of prayer, that we are actually invited to talk and commune with the God who's responsible for the universe. And that, to me, it's so hard for our brains to put together the personal with the enormous in space and time. And yet that's exactly what the God of Scripture invites us to do.
Jennifer, thank you so much for your insights. We have 10 minutes. We have lots of questions, so I'll try and get through as many as possible, and I'll give you the chance to be as full yet brief as possible.
Okay.
Okay. Has your science ever caused problems for your faith, or vice versa?
You know, I think I was fortunate in that even though I grew up in a relatively conservative church environment, we were always taught that there's some mystery there, that God hasn't given us all the details about his creation in Scripture. He's given us just enough that we need to know to understand the nature of God and our need to be in relationship with God, but the details he hasn't given us in Scripture. So that opened the door for me to really feel free in science to observe and learn anything out there, and to know that whatever I study and whatever we discover, it doesn't threaten the God who's responsible behind it, nor our belief in that God. However, it does cause one to scratch one's head, as we see, all kinds of things, especially in the natural history of the earth, where we see all kinds of species that have come and gone, and we see that, carnivorous animals eat one another, and we see, sort of like, well, why is that? And there are some theological approaches to answering that question, but it still comes up. And of course, so I think, if anything, I would struggle with the same kinds of questions that we all do, that are not necessarily science-centered, but questions like, why would a good God allow us to go off and do these terrible things to each other? Why doesn't God intervene? Why does God sometimes heal people and sometimes not? These are the puzzles we have that sometimes we have to simply acknowledge. We don't have all the answers. But for me, science has never been something that has directly caused challenges for me in faith. It's really, in fact, the opposite. The more I learn in science, the more enriched my faith is, the more excited I am about God and God's handiwork and the amazing extent of God's purview. When you think of hundreds of billions of galaxies and stars and planets, and yet we have the privilege of knowing even a tiny bit about this, and of looking out and seeing and using technology for good, peaceful purposes, if we choose to do so, in studying the natural world. This is exciting, and science actually can unite people around the world in ways that nothing else can. The excitement of joint expeditions to explore the oceans or to explore space brings young people together like nothing else, and can really unite the planet. So in some sense, science is a strong friend of a religion of love and peace, and I never really felt a strong conflict there.
Thank you. That actually answers a couple of other questions that differently posed by our audience tonight. So I hope, folks, you're happy with that. Your question has been put, and you are thinking about the answer. Jennifer, then, do you think the existence of an independently evolved life on other planets could or should be considered as evidence against the Christian narrative of a creator God?
So that's a wonderful question, and it turns out that it's not a new question. It seems, as I've looked into this, theologians have been grappling with this question for at least 1,000 years, and you have to ask, why? We didn't even understand our own solar system for that well, and yet for that many centuries, and yet people were already wondering, if there could be life elsewhere beyond Earth, would those, and if that life could actually make choices, would they make mistakes? Would they do wrong things? Would they need the redemption, the help that we believe we need on planet Earth, and that God has given us in the person of Jesus Christ, God coming in the form of a human? Would God need to do the same thing on other planets with other life? This is some of the imagination that C.S. Lewis has gotten into in his writings, and others as well. So my take on that is again, that God, the God of the Bible, is responsible for everything, whether there's a multiverse, whether there's lots of other planets with life. Nothing is a surprise to God. He's provided what we need in our situation on planet Earth to find redemption and to gain what Scripture calls eternal life. And that doesn't necessarily just mean, a timeline of forever, but although it does include that, but it means real life, flourishing life. Jesus said, I have come that they might have life and have it abundantly, or have it to the full, meaning a meaningful life, a life in fellowship with God. And we all sorely need that. We need to turn to God and accept the forgiveness and the reconciliation he offers us through a relationship with Jesus Christ. Now, if there's life beyond, we don't know. God hasn't told us whether they need that same kind of redemption. Maybe God could make a relationship with them in some other form or some other way. We just aren't told. We have a mysterious passage where Jesus once said, I have sheep that are not of this flock that I also need to attend to. And that could have meant, other people on other parts of this planet, but it could also mean other kinds of life. And there's little hints also in Scripture, although Scripture is really designed to speak to the human condition and our needs in a relationship with God. But it mentions every once in a while offhand that God has covenants with other animals on this planet. And so we know that God loves the other creatures on this planet besides just humans, and has given us dominion over those creatures, but we shouldn't be abusing that in terms of using our dominion to abuse, but rather to steward and take care of the planet, including its other creatures. And God has made covenants with them. And God says the whole creation will be redeemed, and the whole creation is groaning, waiting in hopes and looking forward to the return of Jesus, who will reign over all of creation. And so in that sense, I believe we have little hints that God has covenants for the other creatures on this planet of some kind. And also, if there's life beyond Earth, certainly God is relating to them in the ways that they need. And it would not challenge the Christian gospel. That's what we need for planet Earth.
And our last question tonight then, Jennifer, and we're so grateful for your insights, your time, and your openness with us. Our question tonight was, are we alone in the universe? And the last question is, if there is life in the universe, as you've just been saying, do you think it's going to be rare, or do you think the universe is teeming with life?
Oh, what a great question. So we astronomers around the world and a bigger umbrella of scientists and astrobiologists and lots of folks are trying to figure out how to get at this question. Is the universe full of life, or is life rare? And as I mentioned, there are some competing information coming into us that, for example, we know now that planets are common, so that would tell us that maybe life is common too, but that the environments for most planets seem to be rather violent, which would make it difficult for advanced life to form. So we don't know yet, and I don't know, but I'll tell you what my hunch is, which is that since life on this planet seems to be very robust, and simple life seems to have started on this planet early on, I wouldn't be surprised if there are other planets, in this universe where God has endowed it with the kinds of forces and the ability for heavier elements to develop and create the conditions needed for life, that however life got started here, that God could enable life to start many other places. And so I wouldn't be surprised if we can only figure out how to detect it remotely, that if we find evidence for at least simple life on other planets. Whether we're able to discern advanced communicative life is much more difficult. On Earth, it took billions of years for more advanced life to find a niche and to develop. And I just have no idea whether many other planets have that kind of capability. And even if there is advanced life, the distances in space between star systems for which that might be the case could be very prohibitive to having any kind of meaningful interaction, which is a bit disappointing, I know. But so I don't know whether life fills the universe, but I tell you what, since the God that I understand from scripture has enabled all kinds of life to flourish on this planet, in the oceans, in the deserts, in tropical rainforests, even in icy cold places, interesting life, weird life, joyful life, then it wouldn't surprise me if that same generous God that's created a universe with 200 billion galaxies in the visible part of the universe, and maybe an infinite number of others, wouldn't have used those same endowed properties of the universe to enable life to flourish in many places. And it would be too much for us to comprehend. So perhaps God is being kind by just giving us the ability to learn little pieces of information at a time about our greater universe. I hope we all remain curious, that we use our human talents and skills and technology for uplifting things, including scientific discovery and building relationships that are constructive across our cultural and national boundaries, so that we can do things like space exploration together, rejoice and uplift one another and uplift each other's spirits with what we're seeing and learning, and excite the next generation about positive things for the future. That's my hope.
Well, Jennifer, tonight you've excited this generation about what we are seeing and what we're learning. Thank you so much for sharing from your experience, from your expertise. Thank you so much for showing us some of the amazing sites that you see and you work with when you're not answering your emails. And we just look forward to learning more about this great universe, and as you say, about this great God. My guest today has been Dr. Jennifer Wiseman, and this concludes the second series of Questions of Our Times. All of the conversations from both series are available on the Christian Evidence Society YouTube channel. Now, I hope you found our conversations informative, insightful, and above all, inspiring. Thank you so much for watching, and we hope to see you again soon. Goodbye.